So my first paper talked about how the novice user makes sense of visualization that they are not familiar with. The second paper just dive a little bit deeper to let you guys know how, what kind of components should you have to make your visualization impress your readers. The third paper is just based on my current research, like using the social media data to explore the human behaviors. Before I present my work, I would like to let you guys know the way how I organized my presentation. So each paper will be presented in a why, how, what structure. So in the why section, I would like to talk about the background of this study and their research gap or research goal. And in the how section, I would like to talk about the research design in this paper and what kind of methods the author used and what kind of analysis they have performed on their data. In the what section, I will just talk about the results or the contributions or the limitations. So let's take a look at my first paper. My first paper entitled How Do People Make Sense of Unfamiliar Visualizations? A grounded model of novice information visualization sense making. So from the title, you can see like the research goal for this paper is just to figure out the way how people make sense of unfamiliar visualization. So the previous study have learned a lot of the novice users, but the novice users in this paper is totally different because in the previous study, novice user means those people who have little information about make sense of the visualization. But in this paper, the novice user just means the human who have seen a particular type of visualization for the first time. And the previous work was more concentrated in the field of graph comprehension, but they used less interaction techniques. And the other models still have defects in not detail enough how an individual makes sense of a new visualization. So to fill this identified research gap, the author conducted this research. They conducted 3 observation sessions and a semi-structured interview on 13 participants using 3 different visualizing materials. One is a parallel coordinates plot, the chord diagram, and a tree map. All 3 images will be presented to the participant, and they will ask the participant to verbalize what they thought and their behaviors when trying to make sense of these images. And then a semi-structured interview will be given following the 3 sessions. And to minimize the impact of fatigue, they will provide a break between sessions. So after this, all the data will be screening because some participants, they have the prior knowledge of this visualization images. So there are 5 sessions being removed, only 34 remaining sessions. And the authors asked three experts to use the ground theory to code the result. They will use the open coding, which to identify the concepts, and exit coding to identify phenomena, and a selective coding to conceptualizing the phenomena. After this, they will draw an affinity diagram in order to categorize the codes to see the similarities and differences. Here is the novice model that they also developed. As you can see, there are 5 activities in this model, and the arrows here shows the transitions between activities, and the number just indicates the number of the transitions between activities. There are 5 activities. The first activity is encountering visualization, which means the user starts to look at the information, and this is often happens at the beginning of each session. And after this, the participant will start to constructing a frame, like to use the visual objects, the text objects, or the text objects to make sense of the visualization, or they will use the content of the frame to understand the visualization. If they succeed in constructing a frame, they will proceed to the next activity. Otherwise, they will go to the fourth activity or the last activity. In the third activity, the participant began to visualize the images. There are 3 sub-activities within this activity. The retrieving information, the participant will go back to the second activity to use the information to make sense of the visualization material, or they will use their own personal experience to understand the images. Otherwise, they were just wandering around this visualization. And you can see there are many people would go back, revisit the second activity, and they will just turn to other objectives to reconstructing a frame. And if the participant notice some abnormalities, they will go to the fourth activity just to question the frame or doubt the frame, or the last activity, floundering on the visualization. Yeah, I think. And there is one more type of activity which the participant demonstrate other activity. They call it the miscellaneous activities. Here is the dynamics in the novice model. In these figures, the letter 125, the number 125 and the letter M represent the activities. As you can see, in the activity 5 within the PCP happens more frequently than happens in the PCP and the CD happens more frequently than that in the TM. Or the latter activity 4, which is the question of frame, can be observed in the CD sessions and TM sessions, and there are few activity 4 in the PCP session, which means the participant failed to constructing a frame. So we'll go back to the activity 2 or other activities to reconstruct this. This is the figures that shows the transition between activities, the row representing the launching activities. The column here represents the arrive activities. So you can see there are many mutual transition between the constructing a frame and the exploring visualizations here. So this paper, the overall contribution of this paper drew attention to understanding of novice users' cognitive activities, what makes sense of the information visualization. It also laid the groundwork to develop visualization literacy. My second paper, toward a deep understanding of what makes a scientific visualization memorable. This paper talks about what kind of features that contribute a lot to the memorability of the visualization. So many previous studies have proved that our brain is sensitive to a high-level property that guides memory, but they still have limited knowledge on how and why visualization are effective. So what humans see and remember. So this paper trying to fill the gap to understand the visual features that contribute to the memorability. The author proposed 3 hypotheses. One is the memorability may be intrinsic to scientific visualization. The second one is visualization may be easier to remember if it is less cluttered. The third one is the emotional responses may not be correlated with scientific visualization. So they use the images from the science papers, but they curated the data. For example, this data, they are superimposed. They just remove the data here, or they will remove the tables, the diagrams, or charts. And there are many images. They have the multiple images with a single one. They just randomly choose one. They will also use the metrics to conduct experiments. They will use the objective measures like the number of edges within the images, or the feature congestion and entropy. Or they will also ask the participant to use the subjective ratings like the clutter, familiarity, realism, happiness, and interestedness. They conduct their experiment on mTurk, which is the crowdsourcing internet marketplace. There are two types of images will be used. One is the target images. The other one is the filler images. These filler images were used to fill the blank space between the targeted images. And the other function of the filler images is to screen out the participants who didn't pay much attention to this task. So there are two phases in this experiment. During the phase 1, all the images will be presented to the participant within 1 second, and there is a 1.4 second blank interval following. And after this, the participant should press the space bar if they see repeated images. And after this, they will ask the participant to rate the images based on the 5 attributes of the images using a 7-point scale. And after this, they will start to analyze their results. For the correlation result in this table here, for the objective measures, you can find that the feature congestion here is negatively associated with the memorability score, which means that if images have a more feature congestion, they will tend to have a lower memorability score. For the subjective measures, you can see the number of distinct colors is negatively associated with the memorability score, which means this is contrary to their previous study because the result indicate the more colors you will have a lower scores. But they find that there one possible explanation for this would be the clutter effect. This can be improved from these two images here. You can see there are many images, they have more distinct colors, but less structured fashion trend. So they tend to have a lower scores. So this can be improved here. And for the sentiment measures here, you can see like the interestedness and happiness does not statistically correlated with the memorability here. So the contribution of these papers just advanced our understanding of intrinsic visualization, attributability of memorability. They also build a scientific visualization memorability database. My third paper, entitled Interactive Visual Discovery of Movement Patterns from Sparsely Sampled Geotech Social Media Data. This is the paper talked about how to use the social media data to study human behaviors. Social media data have been studied a lot. It contains a rich information of people's behaviors. And people like to post anything in their social media platforms. We call it microblogs. Those microblogs allows you to study the spatial and the temporal information that extracted from the data. But they still have difficulties in identifying the movement patterns. This may be caused by the variability of the data that when and where deposited. And the current analytic tool can be used to analyze the episodic data. We call the data from social media episodic data because this data can be acquired in a predictable sampling rate. So to fill this research gap, the author tried to explore an approach to analyze the movement patterns of social media users. So the data used for this paper is extracted from Sina Weibo, which is a very popular social platform in China. This is similar to Twitter, but there are 4 features of this data. They have large amounts of people and a wide geographic coverage. As of 2018, there are over 448 million monthly active users to use Sina Weibo. And people like to post wherever they want, whenever they want. And the irregular sampling of trajectories. So the movements of the user is hard to track because that may be caused by the different posting habits of the users and the uncertain data, because we don't know there are many uncertainties in the data set, and the movement with the semantic information within the data can provide a lot for you to study the motivation or the characteristic of the movements. So the user proposed an analytic pipeline to guide the users to study the social media data. And based on this pipeline, they designed a visual analytic system. Here's the pipeline for this system. There are 5 components in this system: the data preprocessing, spatial temporal exploration, dynamic aggregation and filtering, detailed analysis based on a certain model, and semantic exploration. In the first component, the analyst can extract the geolocation from the social media data. And for the second component, the users can indirectly play with this data, like to identify the place of interest. The third component is the dynamic aggregation and filtering. Like people can just to explore the spatial aggregation, the temporal aggregation, and attribute aggregation. In the fourth component, the author introduced the uncertain modeling because they are aware that the data with the transition modes would be more reliable to produce the results. So here they just use the Gaussian model to address this problem. And the last component is the semantic exploration. Based on the pipelines, the authors developed the visual analytical system. They first extract the geolocation of the social media data, and then by lining up this geolocation and the posting time chronologically, they can view extracting the visiting sequence of each users. And then they adopt the approach of the density map to filtering the places of interest and deriving movement information. By calculating this density map, the users can drag or resize or remove or delete a place by manipulating the circles here. And in the aggregation model here, you can see like in the inner circle here, the white of the band represents the number of Weibos within each area. For example, you can see the Weibos within the blue region is twice as many as that in the green regions here. And to let the users visualize the periodic distribution of the Weibos, they designed this histogram as clockwise, representing the 24 hours of a day or 7 days of a week. This is the case study they conducted in Yunnan, and this model would be more clear for you to see this They also have the ST matrix view here, which is showing the distribution in geodistance and time interval attributes here. They also conduct the same study in Taiwan. So the contributions of this paper are just to develop interactive visual analytical procedures to analyze the movement patterns of social media users. And they develop a visual analytics system to analyze the semantics of the movement patterns of social media users. So that's the end of my presentation. Questions?
I have a question. You did a nice job at tying them together. I'm still, so for your research, what is your focus that is related to these? Are you still trying to
Just to use social media to explore people's behaviors.
Okay, and Weeby, is that, is there an API for that?
Maybe Python, I think. Yeah.
Have you even tried it out yet?
I have tried to use Python before for my previous project, but just the basic level.
Okay.
Yeah.
And is how, like, so it's Chinese characters, I assume, like, is it like translatable from the, I mean, does the API allow you to sort of extract English versions or put in English and?
I would like to just, like, if I use the API, I would like to just use the Twitter.
Okay.
Yeah. So I don't need
You're going to probably try the next, what was it called that Chris Healy was talking about, that the Nexter or something or the other, that he bought for the library. Because if you try Twitter here, like for the free one, you get like 2 weeks. That's it. So
Yeah,
if you want to do any spatial.
I know there are some limitations for the Twitter API.
Okay.
Yeah. Yeah, because they have only 1 week for if you want to retrieve all the tweets. Only 1 week, 7 days, I think.
Yeah.
So beyond that limit, you have to pay money.
And the problem that we found with Twitter was that by default, the geotag is turned off.
Yeah.
So
I think I might find me a way to.
Because they seem to have so much spatial data in it.
Yeah. I think maybe just use the GPS data to access people's phone, not use their.
How will you do that? You cannot over.
Well,
Really?
by default, it's turned off, and then
Yeah.
it doesn't include the information in
Right.
the tweet unless they give permission to turn it on.
Yeah.
People also use the place that people say they're from. You know.
Yeah, the profile.
Profile.
But
It's a little
it's not reliable.
difficult, though. Yeah.
So is it open source? Do you try to explore how can you integrate with your own application if you want to?
You mean this paper?
This one.
This one, yeah.
This one? Is there online? I'm not sure. Like, they didn't talk too much about how to extract the data here, but I'm not sure that because this is.
Using the whole API for your.
I think because they use the platform in China, Weibo, but I don't think it's the same as Twitter.
Get that with any other platform if you want.
I don't know.
I think most of the youth in the U.S. would like to use Instagram, right?
Right.
Yeah, but
He's asking about is the visualization tool, I think,
The
right?
visualization.
That this paper reports on. If they've shared it on GitHub or anything, the
Is it
tool
open
itself.
source?
No, I
No.
couldn't find it.
Yeah.
Yeah, I didn't see it either.
Yeah, I
Lots
can-
of- I mean, those papers can not necessarily be there because, you know, it's their research, it's their grant, you know,
Yeah.
on their publication stream, and if other people could grab it and build on it, then.
And how do we
Yeah.
continue using this? I mean, if she wants to, she plans.
Maybe I can contact the authors. Come on, we are Chinese.
Because China.
Yeah.
Okay.
I also don't know how much you would have understood even if you had the tool because a lot of that had Chinese characters.
No, at least she can understand we are not planning to use right sheet.
Yeah.
And for the memorability research, I could not get much of it, but then where you can use that? Are you planning to use that for any of your work?
What paper?
The memorability paper, what was it called?
Memorability. The second one?
I think so, yeah. Yeah. It'll go, yeah.
Yeah. So what was the question?
So when do you think we can use this for? I mean, what are do? Can you elaborate once more again? I mean, like just in a.
So if you want to design a good visualization, you have to follow these rules. Like, you don't have, for example, if you don't have to put a lot of distinct colors on your visualization because it might cause the clutter effect. Otherwise, oh, I forgot to mention that there's one interesting finding in these papers.
See that?
Because they noticed that the visualization that contains the faces would tend to have a higher scores, which means people like to view these images with familiar objects. So you see, these two images, they have a higher score than the others. Yeah.
Huh? Okay. I think I'll take offline discussion with her.
Yeah, we can talk about this more.
Sure.
Okay.
Perfect.
Let's let Henry get hooked up. Thank you.
It's like your people glyphs.